Welcome back, folks. We're going to do another mesh problem with a shortcut. We're going to do it even faster this time because I can move through and ask myself the same questions. And by me asking myself these questions, I'll do it out loud. I'm hoping that they're getting stuck in your head because that's where they need to be. If they're in my head, I don't need them. You can have them. So let's take a look at this one. We did it before. So at the end, I'll pull up the notes from the previous problem, and we can compare and see that we get the same result. It's got two meshes, so I know it's going to be a 2x2. I already set that up. There are no current supplies, so I'm not going to write any KCLs. So I'm going to write a KVL for I1 and a KVL for I2. Okay, and these columns follow the order of this, right? So this is the coefficients of I1, this is the coefficients of I2. And let's move through and ask ourselves the questions. What does I1 touch that, and it shares with itself? It's the same, right? When these are the same, we say, what does it touch? It looks like it touches the 6 and the 12, so this one's going to be 18. And then what does I1 share with I2? It shares the 12, and since it's shared, we get a negative 12. Looking at the right-hand side, it looks like I go up across the 12. And that's it. So this is going to be positive 12 on the right-hand side. And we're done with that one. That was pretty quick. Halfway there. Okay, what does I2 share with I1? It shares the 12. So I get negative 12. And then what does I2? Those are the same, right? So what does I2 touch? It touches the 12. R2 and the 12 R3, so this is going to be positive 24. All right, looking at the right hand side, be careful with your polarity as I move around in the direction that we've labeled the mesh current. I'm going positive to negative, so I'm going to drop across the 8 volt, and therefore it's negative. All right, plug it in and get fast with your calculator. 12, negative 12, 24, and negative 8. Okay, and I get 2/3 of an amp and 0 amps. Oh, this was that one that had 0 amps on the right hand side. I remember that now. Okay, and we're done. Let's see, that whole video with my yapping we're at 2 minutes and 40 some odd seconds. It's pretty good. Now we have the mesh currents, and we can say, well, what's VA? Because I think that's what we were really after. Okay, and we do that in the usual way. So we say VA equals I1 minus I2 times 12, and if we do that, we find that we have 8 volts there. Okay, that's pretty quick, even with some talking. Let's go look at what we got previously. And it should match. So I got to pull that up. Let's see. Uh-oh. Where is it? Finding mesh currents. Welcome back, folks. We're going to do another. I probably should have paused, huh? Okay, finding mesh currents 0, 1. There we go. Okay, it's in there. We talked about the siphon because that's how we got 0 amps. But look at here. Hopefully this is showing up for you. Okay. Look at here. We ended up with an equivalent system of equations. Okay. Paste it. There we go. Okay. Some of our signs are different. Ooh, okay. Why is that? I think that this was the one. We didn't follow the rule. Okay, when you're doing the shortcut, label all of your current directions the same. But we did end up with, I said 2/3 here. This is 666.7 milliamps. I rounded a little bit there, and 0 amps. So we ended up with the same solution. Let's look back at that. At this problem, and let me get it up on the screen for you here. Come on, scroll up for me. There we go. And look at this. I didn't follow the rule, so this is going to cause a little bit of a problem. But we got the same solution. That's the important part. This one's clockwise. This one's counterclockwise. So I had been using this one as the example of you can mix and match them if you write them out the long way. If you're doing the shortcut, don't do that. You're going to play with your signs a little too much if you do that. But we ended up with the same solution. Okay, and that's what we want to do, is get to the same solution. Pretty fast. I think we can go faster. We got some other wrinkles that we got to worry about. How do we deal with current supplies? How do we deal with super loops? Things of that sort. So let's look at a few more examples. Stay tuned and good luck.